Okay, question 4. Determine whether the statement is true or false. Give an example to support your answer. A. Square root of p is irrational for any prime number p. This is true. This is true. Because in order for square root of something to be rational, so square root of a is only rational if a can be written as something square, right? So for example, square root of 9 is rational because because 9 can be written as 3 square, right? For example, square root of let's say 4 over 9 is rational because 4 over 9 can be written as 2 over 3 square, etc., right? But there's no way we can write a prime number as something square because prime numbers by their nature, they only have 2 factors, which is 1 and themselves. Okay, so there's no way we can write a prime number as something square. And that's why if p is a prime number, then the square root of p is always irrational. So this is true. Okay. B, the sum of any 2 irrational numbers is a rational number. So for this question, the key word here is any. Because the question has the word any, the statement is false. The sum of any 2 irrational numbers is a rational number. This statement is false. So in order to prove something is false, we can simply give a counter example, right? You don't, so like for now, you don't need to give a full proof because I got this question asking like, is there any way to prove these statements instead of giving examples? I mean, there are ways of proving these with a very formal proof, but you need more math tools in order to do those proofs. Okay, so for now, just give counter examples. Okay. Question B says the sum of any 2 irrational numbers is a rational number. So in order to prove this wrong, you can just give an example where the sum of 2 irrational numbers is irrational. That way you can prove this statement wrong, right? So for example, square root of 2, that's an irrational number, right? Plus pi. So square root of 2 is irrational. Pi is also irrational. And this number is irrational, right? So the statement is clearly false, right? Because it says the sum of any 2 irrational numbers is a rational number. So this is false. Okay. C, the product of any 2 irrational numbers is always an irrational number. This is false. Again, the easiest way here is to give counterexamples, right? For example, square root of 3, that's an irrational number, right? Times square root of 3. That's the product of 2 irrational numbers, right? And the answer will be 3. And 3 is a rational number. So this is a good example to prove this statement wrong. Okay, so C is false. D, the product of any rational numbers is always rational. This is true. Why? We know that for rational numbers, we can write rational numbers as P over Q, right? P q are integers and q is not equal to 0, right? So now we have two rational numbers, P1, Q1, P2, Q2, right? And now we multiply them. The answer will be P1, P2, Q1, Q2. Since P1, P2, Q1, Q2 are all integers, the product of P1, P2 is also an integer. The product of Q1, Q2 is also an integer, right? So P1, P2 is an integer. Q1, Q2 is also an integer, which means this number over here is also a rational number, right? But here, like I said, this is a very simple proof. You don't need to know this. It's good to know. Here, the question is asking you to give an example, right? So you can just give any example. For example, 2 times 3 is 6. 2 is a rational number, 3 is a rational number, and their product, which is 6, is also a rational number, right? The product of an irrational number and rational number is always an irrational number. This is true. Why? You can use the same proof that we use in D, right? This is a rational number, right? It times some kind of irrational number. We know that irrational numbers cannot be expressed in the form of P over Q, right? So even if we multiply a rational number by an irrational number, the product cannot be expressed in the form of P over Q. So that's why this is true. So this is true. The product of an irrational and a rational number is always an irrational number. Okay. Any example? For example, an irrational number, I always like to use pi, right? Pi is an irrational number. And a rational number, let's say 2, that becomes 2 pi, right? And 2 pi is still an irrational number. So this statement is true.